Now you remember this? This is our soil type in North Carolina. It is not the best soil. If you want the most productive soils, Iowa, Illinois. I'm from the south side of Chicago originally, and that's Cook County, best soils on the planet. Of course, it's all city now, but when I was 10, we moved to DuPage County, the county just west, and it's still the best soil on the planet for producing food and fiber. And the reason I'm standing here today, because when I was a senior in high school, DuPage County mandated that all farmland in the county could not be sold as farmland. Industrial, municipal purposes only. So the price of farmland went from $2,000 an acre to $25,000 an acre overnight. But it's the most productive farmland in the planet. That's our biggest crisis in the United States, is the loss of prime farmland to non-farm uses. Future generations got to work on that one. Anyway, the point I'm making here is that for nutrients, this soil that's very highly weathered, we did this already. You've seen this. Good guys. So we've lowered, compared to Iowa soils and so forth, there are less of these. Lots of these. These are the bad guys. And low phosphorus, unless fast management, and low pH. So you got my phone number and email. You won't need to call me and ask me this question, but I get this question a lot. Hey, Havlin, I got this yard. I got this neighbor. Usually it's them. They blame it on the neighbor. I got this neighbor, and his grass just looks like crap. What do you think? Did you soil test? No. He said, well, okay, chances are you got to lime it, and you have to add phosphorus and potassium. Do that, and then let's visit. Usually that takes care of it. So that's where we're headed. So in North Carolina soils, I put the ones here that you likely need to pay attention to. The rest of these, unless it's too much, but in terms of deficiencies, don't worry about it. If I'm in Colorado, this is about problems I'm solving. I got nitrogens around. Calcium, that's rare to see calcium deficiency. Although, if you have sandy, low pH soils, my father-in-law did this on a sandy, low pH soil, tomatoes, pH 4. Tomatoes need pH 6.5, and blossom end rot. It's not a disease, it's calcium deficiency. So lime the soil and good to go. So I took soil samples like a good person would take, took its temperature, and it said, yeah, I add 2 tons of lime. I added 2 tons of lime, and the pH went up to 5. It's supposed to go up to 6. So the lab, something happened. They told me I had 2 tons, and 2 tons didn't work. So I had to go back and add it again the second year, and then we're good to go. He didn't have blossom end rot the first year after liming with the 2 tons, but I got the pH up to where I wanted it with 4 tons. So the lab didn't make the recommendation correctly, and that's all I'm suggesting is on the soil test report, when we get to it here in a minute, there are recommendations and there's data. And I go to the data first. Most people just look, oh, they're telling me to put on 10 pounds of this and 2 tons of lime, I'll just do that. And if that's all you do, fine, you'll probably be pretty close. But I like to look at the data, and you will too, because it's really kind of fascinating. Well, it is for a nerd like myself. But anyway, let's think about how plants get their nutrients. You know, they don't have brains, right? They take up water. That's it. And the water is taken up because there's less water pressure in the atmosphere than there's more negative pressure in the atmosphere because there's less water there than there is in the soil. So the high negative pressure in the atmosphere and low negative pressure for water in the soil causes water to go from here to here. So that's a physical thing. contains cations and anions. I've mentioned this before, so get ready. The good guys are in white or blue, and there's the bad guys. Now, we don't have much sodium, but if I'm in Colorado, I got lots of sodium. But you generally won't have to do that unless you've amended your soil with some kind of waste that is loaded with sodium, and you can find them. That's why a waste analysis report is crucial. I got called out to a field in Wilson, at a potato processing plant. You know, you put potatoes in cans, you got the little boiled potato in the can. How they get the skin off those potatoes, you think? Because don't have the skins on, they're, you know, white potatoes. They got you know, an army of people in there with little paring knives, right? They soak them in sodium hydroxide. Now then, they don't soak them very long, but it loosens up, breaks down some of the cellular stuff in that skin, and then they high pressure wash and the skin comes off. Well, what do they do with the wastewater? Dump it in the lagoon. And then they tried to put the lagoon wastewater on a wheat field. And 6 years later, the soil was so loaded with sodium, the wheat wouldn't grow. And that's what happened. So it's really rare in North Carolina to see sodium, but with waste, you can. Anyway, this is the culprit right here. And I'll show you on the soil test where it is. Anyway, the nutrients are only taken up, plants only take up nutrients that dissolved in the water. That's it. If it's not in the water, the plants can't get it. So when the plants take up all the nutrients that's in the soil water, the next time you grow, there's no nutrients left. Right? Well, there always is, so where did those nutrients come from? There's buffers. There's reservoirs of nutrients that resupply the soil solution, the soil water. And those are, guess what? This is huge. For things like micronutrients, sulfur, nitrogen, and a little phosphorus. These are some minerals, solid salts in the soil that slowly dissolve. Phosphorus is one. Micronutrients come out. We also get aluminum and some other bad ones. And then they got this one called the cation exchange capacity. This is all related to those little teeny clay particles we talked about with the water. Those are charged. Remember, they were charged. They have a negative charge. And that negative charge says, well, I can hold water next to it, but I can also hold cations. And so on the surface of these clays is all these cations. And that's what the soil test measures. It measures, there's a very little in this soil solution, but it does measure that. But it measures these here. It measures the ability of these minerals to slowly dissolve. It measures a little bit of their willingness to dissolve during the growing season, etc. Anyway, so when you send a sample to the lab, they do the analysis. I'm going to go quickly back this and tell you why it's important. This is a wine grape grower that planted his grapes. We're talking about $2,000 an acre. Now it's probably almost $3,000 to put an acre of a vineyard. That's just the plants, not the drip system. And the grapes, these are 4 or 5 year old grape plants. And they don't look 2 years old. Look at how weak they are. No clusters, by the way. Well, I took a soil test, 0 to 4 inches deep. I went down even deeper, 4 to 8, and then went down to 24. And measured pH. I did measure everything in there, but I also measured these 3. And what did the phosphorus show? No phosphorus. 0. I mean, that says that soil is so deficient that this plant should have been over this pole and closed the row. So do you waste time putting seeds in the ground without having a soil test? No, you don't. That's just goofy. That's just not using your brain. All right, so let's talk real quick about soil sample. This is the fun part. You have soil probes here that they can borrow. Okay, good. Good. Don't buy one of these unless you've got several of you together that are working together. Then go buy a soil probe and share it. Anyway, if you've got larger fields, you want to develop a soil plan. If you've got smaller fields, then just take a lot of cores. If you're talking about a half acre, then just make sure you got 20 or 30 cores in the bucket and you're good to go. But if you've got larger fields, like an acre or two, and you've got any kind of elevation change, you want to use that because as a means of designing a sampling plan. Let's say this example field where I've got a higher elevation area than down here. You know, when it rains, what happens? Water runs down, yes? So there's more organic matter down here than there is up here, yes? So that influences that organic storehouse of nutrients, and the soil test levels might be a little higher up here, down here again. So I'm going to separate, I'm going to sample this different, because the recommendations, the inputs are going to be different, even though I plant the whole thing in the same crop. So with steep slopes, I call that a composite sample. I've separated my area into unique places that are different. For whatever reason, there's a number of reasons. I just picked out elevation. But when I decide that's the sample I'm going to send to the lab, then I walk around and get my 20 cores and put it in the bucket. Make sure that I'm doing the 0 to 8-inch sample depth. Not 0 to, if it's turf, it's 0 to 4, but if it's garden, it's 0 to 8. Okay? All right. Anyway, Ashley can help you with that, or we can talk about it. If you're at a home and you've got your garden area back in the back, etc., then again, I'm just walking around that and take my 20 cores. Don't, you know, my turf, that's got to be a separate sample. My landscape areas, those are a separate sample. Anything that causes some variation, make sure those are separate samples. Okay. So, sorry. Anyway, the lab then takes it, takes some, puts it in a flask, takes a salt solution, mixes it up, filters it, measures the concentration of all the nutrients, the pH, and et cetera, et cetera. So that's what happens. The purpose of all this is that for every nutrient, pH and nutrients, we have what's called, and I'll define it again later, so you'll hear this phrase a number of times, called a critical level. So I look at the number on the soil test report, it says 50. That's the critical level for phosphorus. If I'm above the critical level, my soil test is up here, I'm good to go. I don't need to worry about it. I don't buy and apply that nutrient, I'm okay. But if it's below, then it's likely some level of deficiency, either moderate, just slightly moderate, or severely deficient like the wine grape grower was. So here I find myself in your garden, and I take my first soil sample, and I find it's below the critical level. So I start adding some phosphorus. And I sample again next year, and it's up here. And I sample again the year after, and it's up here. Now I'm up here above the critical level. What should I do? I should probably stop. Well, if I stop, it's going to go back down. I'm removing nutrients, right? If I keep adding, it's going to go back up. I mean, it's still going up. What I want to do is figure out a rate that will maintain my critical level just slightly above, maintain my soil test level just slightly above the critical value. That's it. How do I know that? Well, I mean, how do I know what's that right rate? Well, I grow my crops. I can estimate how many pounds per 1,000 square feet or tons per acre of my crop, and I can go in the literature and find out what the percent P is in there in those crops, multiply the mass times the percent P in the plant, and I get so many pounds of phosphorus removed in the harvested portion of that crop. And that would be good to add that back. That's it. And if you're using mulch or organic compost, not mulch, but organic compost in the bag, it's probably got pretty good phosphorus in it. determine how much of that mulch, how much of that waste you're adding, times the nutrient concentration. We'll do that here at the very end, show you how to do that math. Yes, ma'am.
So actually, I think I may have messed up with my sample test because with what we talked about here, in a regular garden, you've really got to go down 8 inches. Is that?
That's what I do. Yes, 8 inches.
I don't think I went that.
No, you probably didn't.
I took the top, which is because we're on clay. We are on solid clay, and so we've only
yes.
putting stuff on top, and therefore the report is just on the stuff on top, not where the clay then comes in. So the amendment is, you know, I've really got to go 8 inches deep.
I think so, because where are the roots?
Yeah, exactly.
So you've got a lot of roots on the surface that are using the nutrients. That's where you've been putting the nutrients. So the nutrients are high there. So my guess is if you're liming and putting nutrients, you're really high up here. You'll never get a recommendation. Everything looks good except for pH. That'll go down. That looks good.
Anyone who wants to talk more about their soil sample that they did earlier, after this, we will talk. Okay? We'll talk you through this.
Yeah, we should have.
I mean, it makes total sense what you said.
Yeah, it'll make more here in just a minute. It'll make more sense here in just a minute. Anyway, you got to know those critical values. The lab does, and that's how they say, well, it's less than 50, so they put a recommendation up here. Okay, and that recommendation depends upon the crop. So some crops need less phosphorus at soil test of 20 than others. Anyway, so then you get this report, and the first thing you do, look at your report. By the way, I'm referring to this one. This is with the yellow, and I forgot to print this one out. Ashley, my bad. This is what you're going to get, this guy. So that's what they all have. They have this one. I apologize. I just didn't print it out. Anyway, this is sample B on this sheet, this guy. Sample B. So if you look across and look at some of these parameters, CEC is 6 and pH is 5.4. You see that? Okay. So you get this report. And the first thing you do is you look at all those parameters and you just want to throw up, right? What the heck does this mean? And you go, God, just tell me what to do. No, we don't want that. We don't want that. We want to understand it a little bit. So, what we're going to do is we're going to break all this apart. Now that's how we don't have enough time. Actually, we do, because it's not as complicated as you think. There are 6 parameters in here that all have to do with liming my soil. So I get those done. The rest of these are just know where the critical level is. That's it. Pretty straightforward. Okay? It's easier than it looks. You just got to know what a cation and anion is. That's it. Okay. You get this report. This is for gardens, hort, turf. And all they've done, they tried to change the report output so that the first time you looked at it, you didn't throw up. They made it a little bit more graphical. But look at it. pH. pH. Phosphorus index. Phosphorus index. Everything that's up here is down here. Actually, they did leave out a few things, which is not good. I have calcium, magnesium sitting here. Do you see calcium, magnesium anywhere? No. This is a huge mistake. I've told them, last deck when they first came out with this, I've told them and told them and told them, why don't you put the calcium, magnesium in there? Because you'll soon find out I need this number to determine what kind of lime to buy. I don't have, and they said, well, we're just going to recommend it and put it in the recommendation line, and meaning you don't have to think. I don't like that. That's government telling me what to do. Now I got to go get a booster. Ugh. Anyway, so 6 parameters. You refer to this sheet. It's the same soil test, number B. We're going to look at CEC, cation exchange capacity, BS, that's the quality of this report of presentation. AC, that's the acids, aluminum. pH, you know that, right? Calcium, magnesium. There it is. 6 parameters. All I got to do is understand those, and I know everything I need to know about liming, whether I need it or not. So let's do that. First thing we need to understand is that sand, silt, clay, and cation exchange capacity. Those particles have negative charges on the surface called a cation exchange capacity. It measures the size of the negative charge, and if I have 10 negative charges, it holds 10 positive charges in cations. Yes? All right, so I got cation exchange capacity. One of the most important properties of soils.
Is it always the higher the better?
No, not necessarily. Not necessarily. But the higher it is, the more nutrients I can hold. Yes. And if I add in, the only way, see, CEC is predominantly determined by the quantity of clay I have. So the more clay, the greater the CEC in general. There's some problems with that statement, but that's a little beyond where we are. I can't change the texture of my soil. Now, if you're in raised beds and I get a couple bags of sand, I can change the texture of my raised bed, yes? It's a small area. Farmers can't do that. They can't change the texture of their 200-acre field, right? But if I want to change the CEC, the only thing a big grower can do is increase organic matter content. So, again, soil, water, productivity, and nutrients. So let's quickly go through, this is my drawing of cation exchange capacity. There's the clay with the negative charges and all the cations attached. Notice I got the good guys and the bad guys. Yes? Keep focusing on the red and the blue and the red. So the greater clay and organic matter, the greater CEC. The more CEC, the more nutrients are held, and potentially the greater buffer that I have to resupply soil solution. So, here it again is a different drawing, but it kind of helps you sort through what I have on the soil test report. So there's my cation exchange capacity. On your soil test it says 6, right? Or 6.3 or something, whatever it says. Yes? Yes. So I got all my good guys and bad guys. Well, that's a lot to look at. So let's separate it. So what do I got? I got the good guys up here and the bad guys down there. That's all I did. Okay? Are you with me? Okay. I just separate. When I outline my soil, I'm changing the bad guy. I'm reducing the bad guys. And I'm increasing the good guys. That's what happens when I'm lining my soil. It's all it is. So let's go ahead and add them up. Well, I add them up. I got 12 plus charges here. And I got 12 good guys. And I got 12 charges of bad guys, right? 12 plus 12. What's my CEC? 24. 24. I mean, it's 24. You yell it out when you know it. Okay? 24. Right? Now think about this. What percentage of the total, which is 24, is occupied by the good guys? 50%. So on your soil test report, I have CEC, sample B. CEC, what is it? CEC, 6. And base saturation percent is what? BS percent. 73% of 6 is occupied by these good guys. In this example, it's 50%. Okay? So if it's 50%, sorry, baseball bat's coming out. If it's 50% good guys, what percentage of bad guys is it? 50%. It can't be more than 100, right? So if it's 73% base saturation, what's the percentage of bad guys? 27. I know that's higher math. 27, right? Good job. You just now know CEC and base saturation percent. You know two of all those parameters.
So like if you were looking at our graphical representation on the home report, would you want to see it be the BS higher than 50%? Like where's
Yes, I'm going to get there. Just you're ahead of me. Yes, but that's absolutely where we're headed. So again, base saturation percent is nothing but the sum of the three bases, the good guys, right, out of the total. So 73% came from calcium plus magnesium plus potassium divided by 6. So, wait a minute. What's the sum of calcium magnesium here? Come on. 44 and 25. 69%. Right? You with me? 69. This is the percentage of calcium magnesium, as I said here. So these two are in here. But this is 73. This is only 69. So what am I missing? It says 59. What the heck? Well, that's not a percent. But what percent calcium potassium is it? 4%. Difference between 69 and 73. That's it. They don't put 4% on there because they know you can do that in your head. And they use this index to make the potassium recommendation. That's why they do it. I don't use percent potassium on the CEC to make the fertilizer nutrient potassium recommendation. I'm going to show you what happens to pH when I change all these. That's why I have 4 A, B, C, D on this sheet. I'm going to get there in just a second. Okay? I got a couple more to get through. Now this is the bad guys. But it's not, you said that if it's 73% base saturation, it's 27% acid saturation, right? Percentage of the CEC? That doesn't look like 27 because it isn't. That is 1.6 units of aluminum divided by the total. 1.6 divided by 6 gives me the 27%. I don't put the 27% down there because all I need to do is subtract that one from 100 and I get 27%. So I can do that in my head. I use this total amount of acid, not percentage, but total amount, to make the lime recommendation. That's why that's on the lime report. I just want to show you the relationship between the parameters. So again, I just need that guy and I need this guy to kind of understand whether or not my garden is going to need some lime or not. And I need this guy to tell me, well, if I'm low in magnesium, I probably ought to buy a liming source that has more magnesium in it, or I need to buy some Epsom salt, magnesium sulfate, increase this magnesium. This is high. This is okay. Doesn't matter. I would use calcitic lime in this case. Anyway, let's keep moving. So here's the relationship. This is a kind of a difficult diagram to initially get, but at pH 7, this axis here is the percentage of the CEC that's either the bad guys or the good guys. When my pH is high, 7, my bad guys are 0. I don't have any bad guys. I don't have any aluminum. There are no acids. I have a high pH. But as pH goes down, yes, then the bad guys are going up. Okay, so let's just do that. And again, at pH 7, I don't have any acids. How many bases do I have? 100%. It's all bases. That BS percent on the soil test would be 100. And the AC would be 0, not percent, but 0 acids. So let's do, there's the pH 7. I have no acids, and I have 100% bases. Notice the 0 to 8. These are data, by the way, out in the wine grape country of Piedmont, just west of here a ways. Anyway, at pH 6, what's the base saturation? pH 6. 80%, very good. And my acid saturation has to add up to 100. There it is. And at pH 5, it's 50-50. So I look at my soil test report at pH 5, and I should see something close to 50% base saturation. And the acid AC value is half of my CEC, or 50%. There it is. So guess what? When I increase pH, my bases go up, my acids go down, these two bases should go up. So let's take a peek. I'm going to go by that. My optimum pH is 6 to 7. I'm going to go by this right now and come back to this in a minute. Sorry. Let's look at this real quick. All right, what is the pH of A? 5. What's the base saturation? 60. Well, Havlin just lied to you. I said it was 50%. Right? Well, okay. Soils are a problem. Are very highly variable. Anyway, 70%. What's the sum of calcium magnesium? 60. So 2% of the CEC is potassium. Okay? So let's raise the pH from 5 to 5.4. What happened? What happened to the base saturation when I went from 5 to 5.4? That's going from sample A to sample B. What's happened to the base saturation? Did it go up? That makes sense. I added some bases, lime. Okay? And what happened to the AC? Did it go down? Yeah. It did. How about the calcium plus magnesium? Did it go up?
Yes.
Yeah. We're going in the right direction as I raise pH. So what happens to sample C? Well, what's the pH? 6.2. And what's the base saturation?
90%.
What's the acid saturation? 10. I went from 62 to 73 to 90%, going from pH 5 to over pH to 6.2. And the sum of calcium magnesium is what? 90? So there's not much K there. And that value is really low, so not much K. Anyway, what happens when I raise it to pH 7? I don't want to do this, by the way. It's a little too high. Unless I'm growing, what's those mushrooms? No, what's those root, you put them, dig up those roots around the trees. Truffles, thank you. Truffles need, pH 9. And you're never going to get to pH 9 with ag lime, by the way. You got to use something more caustic than that. So if anybody's interested in truffles, we need to visit. Because I had a guy out west that, he put on 45 tons of lime, and the pH never got above 8. Anywho, there you go. Base saturation at pH 7 is almost 100%, just like we showed on that previous diagram. The sum of the calcium magnesium here is 93%, so there's 3% of its K, potassium. So again, as I raise pH, my base saturation should go up, my calcium magnesium should go up, and my acids should go down. Well, how much acids do I have down here at pH 7? Pretty small amount, right? 0.6 out of 14 is 4%. So pretty small acids. That's cool. So I'm going to go back because we now know we need lime when I'm less than 6, right? If I'm pH 5, I'm 50-50 base saturation, acid saturation. I gotta increase it. Unless I'm growing blueberries and azaleas or rhododendron acid-loving crops. And Ashley can tell you all about which ones need which. So the optimum pH in most of our crops in your garden are somewhere in here. I wouldn't raise it to 7, but some of your legumes are going to need definitely 6.5, 6.8. At least that's my preference. These are wine grapes. They love high pH. We did a study in some sandy soil, and there's the top growth from pH 4 to pH 7. Any difference?
Yes.
How about some root growth? Let's see. Makes a huge effect. So this lime is definitely something you got to figure out. Okay, so remember this diagram. We start out with 50-50, 12 charges of good guys and 12 charges of bad guys. The total's 24, 50% is good and 50% is bad. This would be somewhere around pH 5. So when I line this guy, I'm going to be changing, I'm going to be reducing the bad guys and increasing the good guys. That's all I'm doing. And so my goal here is to take this from 50% bases to close to 80%, and the bad guys close to the difference, 20%, 25%. So it's okay to have a few bad guys, aluminums, okay. But anyway, we did that. So now I know I need lime. I look at my soil test report, it says pH 5, I got issues. I gotta go buy some lime. So let's think about, well, how much? This is lime rate, just a generic diagram. I got two soils. I got a clay soil and a sandy soil. Clay soils have more cation exchange capacity than sandy soils, but both of them have a pH of 4.5. So again, the pH can be anything, regardless of what kind of texture I have. pH 4.5, both soils. I want to raise the pH. I want to raise the pH to 6. Well, it only took 1 ton per acre, 2,000 pounds of lime to do that in my sand. But in my clay, it took 3 tons, 3 times as much. So I got 2 homeowners or two gardeners next to each other, one on a sand and one on a clay, and they both have the same pH. And the one person with the pH with a 3-ton recommendation goes, "The lab screwed up. I got to apply 3 tons. You only have to apply 1. What happened?" It's because at pH 6, at pH 5 or 4.5, remember 50% of 5, the CEC, is a pretty small number relative to 50% of 20 at pH 5 or 4. So 50% of that's 2.5 milliequivalents of bases I need to add. This is 10. So the lime rate should be higher. So the more clay you have, the higher the CEC, the higher the lime rate should be. So it doesn't matter what the texture is, you follow it matters what texture is, you follow the recommendation and the data. So I know this looks like chemistry, but I wanted to visualize with you what happens to the CEC, on the CEC when I add this product called limestone. So let me orient you. There's my surface of my clay. Yes, got a little, I don't show the negative charges, but it's got negative, and it's holding a bunch of aluminum. So I got a lot of aluminum here. I took out the good guys. So how many aluminums do I have here? Charges? 9. Very good, very good. How many charges of calcium do I have? 6. So I can't remove them all. The aluminums. I can only exchange 6 charges with 6 charges. So let's do it. This is the calcium carbonate, the lime that you put in the bag at the Home Depot, and I threw it out of my garden. It dissolved into calcium. It's a little more complicated than this, but this is a salt, right? Just like table salt, sodium chloride. I put it in water, it dissolves into a cation and an anion. I got sodium and chloride. This is the same idea. I got calcium and carbonate. If I bought a product called calcium chloride, it would dissolve into calcium and chloride, and the chloride would not neutralize any acid. And there are products being marketed today in North Carolina that say this works better than lime, and it's calcium chloride, which means the marketing is not true.
Yeah, I was thinking some of that pelletized lime stays quick activating. Is there?
I'm going to get there.
Okay.
I'm going to get there. Hold that thought, though, in case I don't use those same words.
Okay.
Let's add it. 6 charges went on, 6 charges went off. And you, well, okay, the calcium went on. Now my base saturation is higher. But how did the pH go up? Now, I know this is some chemistry, and you all are very good chemists. I can tell you that. So I'm going to show you, again, what's going on. These aluminums, they're an acid-forming cation. So they combine with, is there water in the soil?
Yeah.
So they combine with water, and guess what they do? They produce this salt, aluminum hydroxide, plus what? That's the hydrogen. But fortunately, when the aluminum comes off into the solution and it produces more hydrogen, I got that guy ready to neutralize it. And there it is. CO3 plus the hydrogens gives me CO2. CO2 bubble off, you can't see that. CO2 bubble off, and my pH goes up because this is going. pH, remember, is a measure of the hydrogen concentration in water. So that's what's being removed. The aluminum is still there, isn't it? It didn't go away, but it's now a salt in your soil, and eventually, 3 or 4 or 5 years down the road, this thing slowly dissolves because I'm adding acid. Rain falls, pH 4.5. I'm adding some other stuff, the residue, microbial oxidation of organic matter produces a little acid. I'm adding a little acid. The reaction goes back this way. I get some aluminum, and it goes back on the CEC. My base saturation goes down, pH goes down. I have to lime again in 3 or 4 or 5 years. So there's no free lunch with lime. It's not a one-time lime it and I walk away. I'm going to have to do it every 3 or 4 or 5 years. So how do I know when to go back and apply lime again?
Soil test.
That's it. I got to go get another soil sample. Find out where I am on that scale between sample A and D, right? I got to find out where I am. That's it. So, please look at the lime recommendations. Did I leave them on there? No, I took them all off. But look at the square. It says recommendations up here. That's all blank. Yes? You see lime and P2O5 and K2O and nitrogen and all that stuff. That's where the recommendation that the lab thinks you ought to apply. That recommendation that they put in that box assumes pure lime. Why do they do that? You can't buy pure lime because they don't know what you're going to buy. You can buy lime anywhere, right? They don't know what you're going to buy, and they don't know its quality. So all they can do is tell you what the pure lime rate is. So let's take a peek. This is the lime product rate that I have to go to the store and say, I need to buy however many tons per acre. And if you don't have an acre, you got square feet, you divide 1,000 pounds per acre by 43.56, it gets pounds per 1,000 square feet. An acre is 43,560 square feet, and you want to shrink that to 1,000 square feet, divide the recommendation in pounds or tons per acre by 43.56. 43,560 square feet. So what happens if, and on your label, you'll have this parameter, Effective calcium carbonate equivalent. There's another one that more labs are used called ENV, effective neutralizing values. Some people like that one better, but it's the same thing. If my effective lime quality is only 50%, and the lab recommended 1 ton, pure lime, but the product I went and bought was only 50% pure, how many tons do I have to buy? 2 tons, that's what it says right there. The lab says 1 ton, I gotta go buy 2. Now if my quality is 80%, and the lab recommended 1 ton, how much do I have to buy? 1.1 or 1.2 tons, right? So the higher the quality, the less lime I have to apply, but the more money it's going to cost you. So I can, you just got to work out, well, what's the best economics, you can do that.
What was the other label on the EC?
ENV, I'll show you that in a minute. You'll have it, it's on your slide. I'll show you that. So let me just explain real quick what the 2 liming values are, 2 lime products that are available. There are actually 3, but these are the 2. That quality factor that's on the label is made up of 2 components, the source and how finely it's ground, because these are just rocks that grind up to various particle sizes. Okay, the more they grind it, the more pure it is. Okay, but the more expensive it's going to be. So I can choose this guy. Do you see any magnesium in that one? No. No. If my soil test said low magnesium, I probably don't want to do that. Otherwise, I'm going to have to go buy Epsom salt or magnesium sulfate or some other magnesium source and apply one more thing. This liming product has magnesium in it. By law, it has to have at least 12%. So if I use dolomitic lime and my soil test is telling me I'm low in magnesium, that's the product I want to try to find. And that's why I said the soil test report by NCDA forgot to put that in there on the garden report. And like I said, I've been asking them to do that, and they just, I think, wow, it's okay. I'm used to being ignored. You heard this word? Pelletized lime. Well, it can either be this or this. Got to read the label. I'll show you some labels here in a minute, okay? I decide which source to buy depending upon how much, if my soil has got enough magnesium or not. That's it. Well, pelletized lime, it's a unique product. When they take the big rocks of limestone, old seabed stuff, you know, they crush it. You think when they start crushing it with these big hammer mills, you think it creates some dust? Yes. They used to just do this outside in the air and dust blew away. Well, it turns out that dust is the finest particle, most reactive, and has the greatest liming value. So now they do it inside and suck all that dust, save all that, and then mix it with some chemicals that are water soluble, no harm to the soil organisms or your plant or anything like that, and make these little pellets, BBs. And they are immediately dissolved. Boom, done. You want to raise your pH quickly, like I'm getting ready to grow legumes or something, and I forgot the soil sample. I hurry up and get a soil sample. Oh my God, I need 2 tons, and I'm going to grow soybeans here in 3 months. You better apply pelletized lime because it reacts immediately.
Is that the quick dissolve?
Yes, that's what you were talking about. It's pelletized lime. It's very finely ground. The only difference is it's all the finest particles, so they immediately react. When you grind it up, you got this distribution. I'm going to show you a picture of it in a minute. This distribution of little teeny flower-sized particles, pelletized lime, versus some larger chunks. You can actually see them. And the big chunks don't have any liming value at all. Eventually, they will dissolve, but not in a 3 to 5 year time period that I want my pH to be raised so I can have good yields. Anyway.
It's really expensive, the pelletized.
Yeah, more expensive. Not really expensive, but more expensive. Like 2x, 1.5x. Home Depot, I think, charges $10 a 40-pound bag, something like that. I might be wrong about that, but the last time I looked. And for ag lime, was about $6, 5 to 6. But pelletized lime, you know, if you're doing one of those little whirligig spreaders, you know what I'm talking about? Yes, spreads it out. Do not put ag lime in that spreader. It won't go through the holes. It will not go through the holes. You'll be digging it out of your hand and throwing it out of your garden by hand. Just do it by hand with ag lime and you're good to go. Pelletized lime falls right through. It's just like grass seed. Goes right through and it's easy to spread. No dust. The other stuff has dust, so it's easy to do. Anyway, I wanted to share with you that the total lime quality, this effective calcium carbonate, which we also use as ENV, is a product of the source. That's this guy. And I think why they use ENV instead of this is because we got a lot of C's and E's and stuff in soils. I didn't come up with this. Remember CEC? Cation exchange. Now we got CCE. Now we got ECCE. It gets a little overwhelming, so they use ENC. But anyway, it's a combination of what source did I choose and how finely was it ground. So the finely ground stuff, you can see, here's the big chunks, and here's the flour. On the bag, it'll tell you mesh. I want you to understand what a word mesh means. Your screen door in the back, it's the number of little crosshairs in an inch. So if I want to keep out mosquitoes, I don't have an 8 mesh screen door. They'll go right through that. But a 20 mesh will keep them out. May not keep a no-see-em out, if you know what a no-see-em is, but I got a finer mesh. Anyway, the finer it's ground, the faster. Matter of fact, if I'm greater than 8 mesh, that's, see 10 mesh? If I'm bigger chunks than this right here, I give no value. No neutralizing value in the 3 to 5 year time period. If it's medium-sized product, right in here, only 50%. And if it's really small, down in here, flour, that's 100%. So that's why pelletized lime reacts faster. I still need 1 ton of lime. It's just going to react faster. I'm not going to use less lime just because it reacts faster. Remember, I need to neutralize so many charges of acid, I'm going to have to add so many charges of lime to do the job. So let's think about this fineness and what effect it has on pH if I use the big chunks versus the little guys. So here's pH in a soil where I don't ever apply lime. It starts at a 5 and it keeps going down. I'm not paying attention, right? No soil analysis. And then I put the big chunks. Well, eventually it starts going up, but it didn't go up much, did it? It just not enough surface area to dissolve. And then I start to get them finer, and then it goes up and finer and finer and finer. Look at 100 mesh goes right up, quick reacting. Boom. But still, this is ag lime right in here, and it takes a year, year and a half for it all to react. So if you're looking at planting legumes, you've got to give it a good year for it to react before your pH is up where it needs to be. And if you've sampled 0 to 4 inches, and your legume roots go to 8 or 10 or 12 or 15 inches, you probably want to make sure you're doing a 0 to 8 inch soil sample so that you can add the right lime rate. Anyway, I'm going to go through this a little quick, but it tells you and here I'm using ENV instead of ECCE, but they're similar. Notice it's the product of the source. I find this stuff on the label. I wanted you to remember that if it's only 50% pure, the lab says I need 1 ton, and I go to the store and it's only got an ENV or an ECC of 50%, I need to buy twice as much. My brother has a vineyard in Oregon, and he called me up one day and he says, I don't know what the hell happened, but I put lime on and I don't think my pH went up. Well, what'd you put? I put 1 ton, that's what they recommended. Well, what product did you buy? It's 50% pure. So he put on half the rate. That's what happened. So don't make that mistake. So again, your lime quality is never 100%, unless you really want to pay for it. And then you can find some, but it's rare. So I want to give you an example, just to show you how we do this. And the reason why this is powerful is because there are some liming products that claim some really wild things about you buy this product and you only have to use just a little bit compared to ag lime. And they're wrong. They're not telling you the truth. And how do I know, keep them honest? How do I know not to make that mistake and buy the wrong product? Is having some knowledge. So, again, remember the big chunks get no value, the medium-sized chunks get 50% value, and the small guys get 100. So we're going to assume this particle, and this is all on the label. In this product I bought, I don't have any of the big chunks. This is on your slides. In this, I'm sorry, it's 8%. So 8% times no value is 0. 32% is in the medium-sized particles, and I give them half value, so 32% times 0.5 is 16, right? 60% is the flour, and it's 100%, so that's 60. So I added up, so my fineness is 76%. 3/4. So if my source had impurities and it was only 90%, my particle size was 76, my final product quality is only 68%. Now remember that curve that says if the lab recommended 1 ton and I go to the store and it's 50%, I need 2 tons. Well, this is 68%, so I need like 4 tons? Anyway, a little bit more than that. So again, if my lime rec from the lab is 1 ton, divide by 0.68, and I need 3 tons. I need another 30%. So I'm doing this 2 reasons, just to make sure you don't apply what the lab tells you. You gotta adjust it for the lime product you buy and the labels on the back of the bag. And if you buy it by a big truck because you got a big farm, you gotta get the lime dealer to give you the label. And guess what? They give you the bill, no problem. But unless you ask for the label, they won't give it to you. But usually when you're ordering the truck, you've already made the calculations. They've already made the calculations for you. Again, whirligigger do not work for this ag line, only works for the pelletized. If you're small areas, you know what you got to do by the bucket. This is this product that's been on the market, and I had an older woman that built a 5-acre vineyard out west, and went through all the lectures with the wine grape growers that I do on this over the years. And she called me up one day and said, I made all the calculations, I looked at the soil test report, I knew I needed the lime, et cetera, and the salesman came around and said all I needed was 25% of the regular lime and I'd be good to go. It's 4 times as much money, so she paid out the nose to get it, but she thought she'd get the job done. So I said, well, send me the label. She couldn't find the label, so I actually logged online and got the label. And there's the label, so let's take a look. There's the source, 91%. There's the effective neutralizing value, 88.27. There's the ECC. I thought these were the same. There's a difference in water content between these two, but don't worry about that. I don't know what a lime score is. I called these guys and asked them, please define me what a lime score is, and they said, well, if you don't know, I'm going to tell you. I said, okay. But look at this. This is how finely this is ground. 100% past that big screen, which means none of it's the big chunks. None of it's the middle size. 5% is the middle size. 95% is the flour. So I'm going to do that math I just did. Here we go. 5%, none of it's the big chunks, 5%'s the little guys, 95%'s the flour, right? Right off the label. And that adds up to 97.5%. Oops, sorry. Oh, I wanted to make sure you saw that it was 95% 60 and 5% the other, and that the CCE was 91%, but I got the 91% right off the label. This is the calculation of the fineness, and my fineness was 88.887. So I'm going to go back to that label and show you that the ENV was 88%. This is a value that's less because of the water content. Anyway, so my recommendation is 1 ton. By that I needed 2,200, I needed 250 more pounds than the 2,000. She put on 500 pounds, because that's what the sales guy said, 25%. She put on 500. And so no wonder your pH didn't go up. You can buy this product. And gardeners are especially a hot target for this. So be careful. You already have it written down. They don't like me, this company, by the way. Anyway, I want to show you one more, and then we're off to the races with fertilizer, and then we're done. And the fertilizer is really short, so we're almost done. We have time for questions, Ashley. This is a new one that came out 5 or 6, 8 years ago. It's called AgriCal, and look at what it is: 10% calcium. Sorry, 10% calcium, but not calcium carbonate. Calcium chloride. So, and this is all the marketing. And I love this. Dissolves natural lime in soil. What? Natural lime, dropped me off blindfolded in Colorado, and those soils are called calcareous soils. They have calcium carbonate in them already, naturally. That's why their pH is 7.8. It's buffered at pH 7.8 or 7.5. I don't know what that is. And of course they say all this good stuff. Supplies calcium for several years, no need to wait, it dissolves lime, it dissolves all kinds of crap. So here's the chemistry. This is why chemistry is so important. The calcium carbonate is just like sodium chloride, dissolves into sodium and chloride, in this case calcium and chloride. Did it neutralize the hydrogen? It's still there. That hydrogen is still on the product side. It's still there. Didn't go anywhere. pH can't go up. Can't. No chemical reason for it to go up. Now, if I'm using if I'm growing blueberries, and I got calcium deficiency on my blueberries, I don't want to raise the pH. This is a beautiful product for that. But not for crops that are pH 6.5, where you need high pH. So azaleas, if I've got calcium deficient plants of various plants, this is a great product, but that's the only place it works. Anyway, again, it's not a liming material because I need this carbonate. The carbonate reacts with the hydrogen, and I get CO2 and water. You recall that from a previous slide. So, gosh, a little knowledge of basic, simple chemistry that we all got in high school is a really powerful thing. I know we've all forgotten it, but it's okay. Anyway, please be careful about soil enhancement products. There's a ton of them on the market for organic matter and soil health and all that. Increases your biological number of bacteria, and that helps all these great things. You get 20% yield increases, and they claim all kinds of stuff. Just be careful. All right, so we're off to this last bit, and this will be really fast because this is simple. I just need to take these values, these index values, PI, KI, manganese, zinc. Don't worry about the AI that is beyond today. We can come back and visit about it. There's explanations, but when these guys are above 50, I'm good to go. When these guys are above 25, I'm good to go. Now that's pretty straightforward. I don't even need to show you any more slides. I just look at my soil test report and say, well, I need phosphorus. This one's 59, that's pretty close. I like to kind of keep it maybe 20% above 50. So we're talking about, you know, not a whole lot, 10 points, so that's almost 20%. 20% above 25, these are all good to go. Again, micronutrients are never a problem. You see iron, by the way. Iron is a really important micronutrient to plants. You see iron on the soil test report anywhere? No, because our soils are generally so acidic that we have tons of iron in our soil. They measure it in the lab, they just don't report it because it's not needed. You'll never have iron deficiency in North Carolina. Anyway, these recommendations are all based upon a really simple thought process that says when my soil test is above the critical level, my soil is meeting all the needs of my plants. I don't need to go by and apply anything. My soil is meeting all the needs, therefore it's 100% sufficient, my soil. But as the soil test level, PI, KI, zinc I, etc. on your soil test starts to go down, the soil's ability to meet the need of my crop decreases, and I need to replace that by buying and applying some product that contains these nutrients. And again, I don't care. Remember those wine grapes that weren't grown at 0? Well, you don't get any worse than that. So the rate's really high for that case. Anyway, this was the whole idea. If I find it below the critical level and I start building it up, I got to decide. The only way to know where you are relative to the critical level is to do regular soil analysis. So again, for these macronutrients, this is on your slides. Critical soil test level 50, good to go. Above 50, good to go. I always use like 20% higher, so I always use 60. And the only reason that is because if I take an area of this, my area of the garden, the average composite sample might be 50, right? But I could have a spot over there that's 30 and a spot over here that's 70. And the average would be 50, but that area is going to be deficient. We're going to be lower yield. So I make sure my decision point is a little higher. That way I got everything. I got it covered. Okay. For macronutrients, 25. And again, it's rare to see, especially if you're using organic material. Okay? So that's really quite simple. The recommendations are based on soil test values, but also crop demand. Crops vary. And I can't give you a whole list of them, but you can kind of see here's some field corn and here's tomatoes and snap beans, and you can see there's variation in nitrogen, phosphorus, and potassium requirement. And so my recommendations are going to be different. The soil test report says it's 10 phosphorus. So for corn, I need about the same amount as I need for these sap beans, unless the yields are different. But you can pounds per ton of production, so that's about the same. Wine grapes, nitrogen and potassium are almost the same. Actually, wine grapes need a little bit more potassium than nitrogen, so it just depends on the crop. So be well aware. Oh, I did print it out. I didn't hand it out. That's what I did do. I didn't hand it out. Anyway, there's what you'll get. So again, you have your pH. It tells you there's your optimum range. If you're down here at azaleas and blueberries, your optimum range is that's good to go. 4.9, or actually you need to drop it a bit. And both this soil report shows I'm below 50. I said 10% higher, so they put a line in there so that's really where you want to be. If you're up here, you're good to go. But they don't put that calcium in here, so you really don't know. Now you can get the data. They have the data. So when you send this report, you print this out. You get a choice from NCDA. You print out the PDF or download an Excel file. You get a choice. Download both, then you got a hard copy if you want. And download Excel file, and the percent calcium magnesium are on that Excel file. So get both. Yes, sir.
So with the line recommendation on our home test report.
Yes.
You said like, well, we'll just recommend what the line we need, but is that still based on pure line?
Yes.
Does it still need
Yes, sir.
The math?
Yes, sir. You need to find the product, make the adjustment. Yes, sir. Yes. Beautiful. You got it. So I'm going to pass by this because most of you are not going to do this because you're not going to, you recommending that they pull sample? Okay, good. You're not going to be taking tissue now. I just want you to know that you're going to see visual symptoms. If you have nutrient problems, you don't want to get there. If you see a symptom, you're messing up. Go back and resample and apply the right thing, and you should be okay. So I'm going to go by some of this so we can leave time for questions. And that too. So I just want to talk about sources. Okay? We can come back and talk about plant analysis, but I only use plant analysis on wine grapes, tree crops, peaches, apples, Fraser fir trees, woody species. Those are plant analysis. That's how I determine if things are going good, not soil analysis. Anyway, I get criticized if I'm standing in front of an organic grower group by this slide because they don't believe this. Fertilizers are bad. Mismanagement of fertilizers are really bad. Yes. Have we had problems with environmental quality by over-applying fertilizers? Absolutely. Absolutely. I farmed when I was a kid and young kid. I know I'm from Chicago, but I did end up on a farm for 5 years, married into it. And back in 1978, nitrogen was 8 cents a pound, so heck, I could put 400 pounds on, no problem. That's bad. a lot of it was lost. So again, used properly, and the salts don't hurt the soil. You get all kinds of reasons. They're all environmentally stable, all environmentally safe. But I do prefer organic sources when they're economically available. And the reason is because of all those things we already talked about that improve soil health. If I need to add carbon, I'm going to try to find an organic source. But don't hesitate to use fertilizer when you need to. Just don't over-apply, that's all. So again, these fertilizers are nothing more than we've been talking about, just nothing more than salts. You recognize potassium chloride like sodium chloride on your dinner table. It's the most common salt used in agriculture. Ammonium nitrate is hard to find anymore because it's used for explosive. What's his name? Timothy McVeigh in Oklahoma City took care of that. So you know when you buy fertilizer, you're aware of the 3 numbers. This is not P and that's not K. It's P2O5 and K2O. It's a fertilizer expression, but the recommendations by the lab, if you look on the soil tests, they don't say P and K. They say P2O5 and K2O. So you don't have to convert. It's pounds of P2O5 per acre. Good to go. And you get all kinds of fertilizer. Anyway, there's the animal waste. The problem with animal waste is generally the nutrient content is a lot lower. So the fertilizer grade of an animal waste product is really small compared to fertilizer. So you use less fertilizer than you use. And I'm not going to go than you do in animal waste. So I'm not going to go through this any details other than to orient your attention. So when you're sitting there watching NC State lose to Carolina again in football, you've got something that you can refer to enjoy the afternoon. So all I've done here is take a bag. I'm going to go to this real quickly. Take a bag of this I found this product on Home Depot. Okay, 12.57. My recommendation for my garden is 4 pounds per thousand. You multiply that by 43.56, it's about 180 pounds of N per acre. And I take and it's a 50-pound bag. I don't know, 50-pound bags are getting harder and harder for me to lift. So, each bag contains 12% N, right? So 50 pounds times 12% means each bag contains 6 pounds of N, right? So if my soil test report says, my recommendation says I need 4 pounds of N per 1,000, there's 6 pounds in a bag, so all I need is what, 2/3 of a bag? I have a third bag left over. What do I do with the third of a bag of fertilizer? I put it on my shrubbery, my landscape areas, but don't overplot. That's it, don't overplot. And how do I know then how much P and K are in there? Well, if I'm putting on 2/3 of a bag, and each bag is 50 pounds, this is on your back, 2/3 on the back side. Each bag is 50 pounds. I'm putting on half a pound of P2O5. It's 5%, sorry. I'm putting on 1.68 pounds of P2O5. If my soil test recommendation says 2 pounds of P2O5 are needed, I'm pretty good. But if it says I don't need any phosphorus, then I'm way over applying. I probably ought to go back to Home Depot and buy something that doesn't have any phosphorus in it, because I don't need it. Or something that doesn't have any potassium in it, I don't need it. That's all this calculation is to show you how to do that. The other thing that I wanted to share with you is that I also did, and I'm not going to go through this in the same detail, I just wanted, there's my composted cow manure, Home Depot. Notice the fertilizer was 12.57. This is 121. So how many bags do I need? 8, not 2/3. So when you're using compost and you got a pretty large area and you need a lot of bags, why don't take the Prius to load it up, because you're going to need a bigger truck.
Well, you ruined 10-10-10 for me.
10-10-10 is a great product because, again, for fescue in my yard, I use a lot of 10-10-10 because I know I need P and K, and fescue always uses nitrogen, so I get by. And that's the least expensive grade you can actually buy. Anyway, yes?
If we wanted to improve our soil health, and we talked about the no-tilling method, do you recommend top dressing with organic matter, or just say in garden beds, for example? What do you think is a better?
Keep in mind that the soil is a living organism. There's so much life in the soil. I can top dress a layer of carbon, whichever residue or material, compost, whatever you want, and it doesn't take long for the microbes to start to incorporate that all on their own. It just depends on the aesthetics, what the residue looks like between, like I was talking to somebody, she left I think, yeah she left, about kitchen waste. And everything that comes out of my house goes in the landscape beds. So if I have somebody over or something, there's old broccoli stems and there's all kinds of crap laying all over the place. But every time I mow the lawn, during the winter, it's usually more problematic. But when I mow the lawn, I just cover my landscape, cover those vegetables up with grass. And 3 months later, you take that off, and you can see a big old chunk of broccoli stem. But cut them up smaller, and they break down, and the soil takes care of itself. I don't ever incorporate that stuff. I just let it go. I don't put, chunks of beef fat and that kind of stuff, something that will attract the flies and all that stuff. You don't do that. You gotta incorporate that stuff. Yeah. That's a good question. What else? We're done.
So, I've never lied.
Or we just started.
I've never lied, but, I'm trying to understand. So it seems like a lot of, in agriculture-wise, a lot of people are testing soil over the winter so that they can get ready to do fertilizing and maybe liming before the growing season. Is that accurate or like?
Yes.
Okay.
NCDA has, not for us, but for farmers, free soil analysis. Can we get away with sending them in the free soil testing months and?
We do free April through Thanksgiving.
Yeah. So there is a low,
Right.
but they get 400,000 samples a year, mostly from growers, not just
Sure.
ag, and so they charge them $4 a sample now during the peak season, but there's a period of time when they don't charge. And of course, the problem is with that amount of samples, if you send it in at the wrong time and you need an answer in a week, don't send it to NCDA, because you won't get it back. Send it to Waters Lab, and I'm fine with competing, they're not us, NCDA is not NC State. Send it to Waters Lab, now you'll pay $8 a sample or whatever it is, but you'll get the answer right back, and then I can make my adjustment quickly, if I need to make quick decisions. Ma'am?
So are there right or wrong times of the year to lime? Like-
All you want to do is just make sure if you're using ag lime and you need that year for it all to react, you want to make sure you give it that year, especially if you're growing legumes. Like for wheat, corn, soybean growers in North Carolina, I always try to apply the lime in the fall or the spring, fall right after soybean harvest, or spring right before corn planting, because corn only needs like 5-6 pH, but soybeans need 6.5. So apply the lime before corn, then I grow the corn, I go through all the summer, and then I got a whole another 12 months before I come back to soybeans, and my pH, my lime should be reactive. Don't have to worry about that if you spend the money on pelletized lime. It'll go up in a month or two. Somebody else, yes? No? Okay, sorry. Yes?
Sorry, I'm not trying to dominate the questions. So I just ran into Cheryl outside, and she made a statement that this was like drinking from a fire hose, which is a little bit like what I feel like right now. So I just am like, if you could give me some like nuggets of like, if there's anything, like you had to narrow it down to like 3 to 5 things that we need to make sure that we either like, spend some more time with, that we walk out of here
Yes.
with, like, just to,
Okay, real simple. You really can't change the texture of your soil. So your water, things we talked about are going to be what they basically are unless you start increasing organic matter content. So don't worry about that. What I want to do is if you have low organic matter and it's a degraded soil and you're trying to upgrade it, figure out what I can do to either grow cover crops, live crops, or residue in the non-crop periods. When I'm cropping, make sure there's something that can go between the rows to keep those row middles covered. 365 days a year, cover your soil. Very important. And then the last thing is soil test. Lime, P and K. If it's an old tobacco field, P and K should be okay, but the only way to know is so, and don't take a 0 to 2 inch sample. If you're dry soil trying to take a 8-inch sample, you gotta have more than just a physical push probe. You gotta have one of those hammer probes in clay soil. I should have brought one, Ash. Do you guys have a hammer probe?
No, but we have one that when I put all my weight on it, I can drag it and it's got teeth on it.
Okay, you know what I'm gonna do? I can't do it right away, but I'm gonna bring you a hammer probe next time I come.
Good question
Okay.
from the back. Don't use hammer probe.
Hammer probe, it's 7-pound slide hammer, and it goes right in 8 inches. Oh, yeah, make sure you mark it 8 inches, because you drop that thing 12, 14 inches before you know it, especially with some muscle. Yes?
What you just said, is that the same for a grass lawn?
Yes, except I'm not gonna mulch that,
Right.
right? But I can still use, during the non-growing period, I can still sprinkle a little layer of compost on it and rake it in and get, so I don't kill the grass, but I can still blend that in. But I don't normally do, that's pain in the neck. To me, it would be painful to do. I would just do the nutrient thing and then monitor my watering. Don't excessively water and don't underwater. I mean, there's a guy in Briar Creek, I don't even know this area, but you know, these big fancy golf course communities, everybody's got an acre or whatever, and they all got fescue, and it's green all year long, and they got, you know, it's a couple $1 million house or whatever, and it's got about $1,400 a month in a water bill in July and August. And wondered how he could, you know, reduce his water bill. Well, I showed him how to do the calculations, and he was okay with that. It says either that or tear your fescue out and plant Bermuda. Warm season grass uses less water. But which they convinced, the homeowner association was convinced to do that. Everybody was going to switch to Bermuda, and so about 30% did, tore out their fescue, and then of course Bermuda turns brown in the winter. They didn't like it. They all went back to fescue.
Also, just like leaving clippings with turf, right? Keeping your mowing so that your mowing and your clippings are short enough that you can just mulch and basically put all that right back down. Otherwise, you're just continually removing
Yes.
what would have been your mulch.
Yes.
Right?
See, I remove all my grass clippings. I catch it all because I use them in my garden. And
Yeah.
I do remove those nutrients, but I'm a dirt fert guy, so I apply nutrients. So I'm putting them all back, but I'm recycling them somewhere else. I don't fertilize my garden and landscape areas. I never sprinkle in, I don't. That's all grass clippings and kitchen stuff. And yeah.
My question, what about if you don't have access for one reason or another to be able to test the soil, and you still have to like do a job or something like that?
Oh, you mean you don't have a soil probe?
I don't have a soil.
Yeah, well, she has one, so you get hers. Okay. And there's a way to do it with a sharpshooter or spade to collect a sample, and you can show them how to do that.
Okay.
Yeah, just make sure you dig a V 8 inches deep, and then clean off the edge, and then take an inch off one of those V's, and that goes in the bucket. And do that your 10 or 20 places, and you're good to
Well,
go.
I think what I was
Oh,
thinking
I'm sorry.
was like, you know, let's say you're working with a client, right, and she says, I want to get this taken care of in the next week, and you don't have the time. She's like, oh, I just want to see things here. I need to see color. I need to see this, and you don't have time to be able to get a soil report done.
Well, I've been asked that question 1,000 times, and my answer is going to be the same, but I want you to know I'll take no liability. That most of our soils are low pH, low P, and low K.
Okay.
So, and if I'm in a lawn, I'm gonna, somebody said 10, 10, 10, right? I use 10, 10, 10 plus lime. So I'll put a ton of lime on in the fall or early spring, like January, February. Get that lime to dissolve, and then at the same time put 10, 10, 10. Or 10, 10, 10 just as it starts to regrow. Yeah. But, you know, just make sure you're not putting in, I can't tell you how many bags to apply because I don't know the area that you're talking about, but we can figure that out really quick. The example here, just put 10, 10, 10 instead of 12, 5, 7, and you can figure out how many bags to buy.